Hello class, this is Econ 510 Managerial Economics class. Today is March 10th, Thursday. We will finish up the comparative market today. So here is the order of today's video clip discussion. 1. Comparative market and efficiency. 2. Comparative market animation of fixed and variable cost. 3. Perfect competition. 2. For the types of markets. 5. Economic animation of cost curves. 6. Economics animation for do we really need all diagrams. Here is the first video clip.
Firm doing. We're going to take one more look at a profit maximizing firm doing the best it can. In this particular case, it's going to turn out that the best the firm can do is to shut down. Let me start with a question. Under what circumstances would you, a manager, find it optimal to shut down your factory in the short run? The answer is this. You're only going to shut down your factory in the short run if you're making a smaller loss by shutting down than you'd be making by staying open. The firm's making a loss, of course, but sometimes you can minimize your loss simply by sending all of the workers home and shutting the factory down in the short run. Let's see how that works. Suppose the price of television sets now is very low. Let's suppose it falls down to maybe $200 per television set. In that case, what's the best the firm can do? If the firm continues to produce, what output will it choose to produce? Use the same rule that we've been using for the past 4 segments and find the point that the firm will choose to maximize its profits. That's going to be going over to the marginal cost curve and finding the place where price equals marginal cost. That's the profit maximizing point of output. And if we go down here, we identify Y star, the output level at which the firm is maximizing its profits. Uh-oh, look, I forgot to label my axes again. If you don't do this on a test, you might lose points. So let me try to encourage you to develop a good habit. Now that my axes are labeled, once again, this picture means something, and we may proceed. Now, here's the firm's total revenue, price times quantity. However, notice in this case that total revenue happens to be exactly equal to variable cost. If you take Y star and go up to the point where you touch the variable cost curve, notice you're right at the point of minimum average variable cost. Here's a good review question. How do you know that this point that I've touched here is the point of minimum average variable cost? How do you know that? Here's the answer. You know it because the marginal cost curve cuts through the average cost curve at its minimum. And since we're at the point where price equals marginal cost, and we're also touching average variable cost, we must be at the point of minimum average variable cost. Here we are at the bottom of the average variable cost curve. So if we multiply average variable cost times output, we get, once again, the familiar term variable cost. So look, in this case, our total revenue is just equal to our variable cost. What does that mean? It means that we're spending all the money that we are earning selling television sets to pay the wages we owe our workers. Nothing is left over. All of our revenue is consumed covering our variable costs. And unfortunately, those aren't the only costs we have in the short run. In addition to the variable cost, if we go up to the average total cost curve, we're now including the fixed cost. The difference between the average total cost and the average variable cost curve is average fixed costs. And if we multiply average fixed costs times the total quantity of television sets we produce, we get another layer here of a parfait. Here's our fixed costs. Unfortunately for this firm now, however, all this fixed cost is lost. The firm has no revenue to cover the fixed cost. It spent all of its revenue down here covering its labor costs. So fixed cost, all of the fixed costs are a loss. In this case, the firm's loss is exactly equal to its fixed costs. It has no money to cover its fixed costs. So, should the firm shut down? Anytime a firm shuts down, it loses its fixed costs. It makes no money to recover them. However, if this firm were to continue to operate doing the best it can, it's going to lose all of its fixed costs anyway. It's going to spend all of its money just covering its labor cost, and there's nothing left to go towards the fixed costs. So when the price falls to the point of minimum average variable cost, in the short run, the firm is indifferent between continuing to operate and shutting down. Suppose now things get even worse. They can get worse, you know. The price could fall even lower. And if the price falls even lower, now the firm, doing the best it can, cannot even afford to cover its variable costs. In that case, if the firm operated, not only would it be losing the amount of its fixed cost, it would also be paying workers and incurring a variable cost that's greater than its total revenue. If the price falls below minimum average variable cost, this firm would be making an even bigger loss. It would be losing all of its fixed costs, plus it would be paying workers more than it was taking in selling its television sets. That would be completely ridiculous. No manager would ever operate a firm that could not cover its variable costs. You'd be paying workers to come in and drive your firm into the ground. You'd be paying waiters who weren't serving enough food to cover the cost of their wages, much less the rent on the building, the overhead costs, all of this. You would shut your restaurant down rather than charge a price that doesn't cover the cost of the waiter's services. Same thing is true with our television sets. If the price of a television set is not enough to cover the labor cost, much less the fixed costs, if it's not enough to cover the labor cost, you do better in the short run by shutting down. So here's the rule a manager should use. If the price of the product drops below minimum average variable cost, in the short run, that manager should shut the firm down. You minimize losses by shutting down the factory. If, however, the price is greater than minimum average variable cost, if you can operate and cover variable costs, then continue to operate in the short run. At least you're earning something towards your fixed costs, rather than losing them all with no revenue to show for it. That's why we call this point, the minimum of average variable cost, the shutdown point. Now, notice, if the price is below the shutdown point, the firm is going to be shut down. If the price is above minimum average variable cost, the firm is going to be producing where price equals marginal cost. That is, for all prices above the shutdown point, the marginal cost curve tells us the quantity of output that it will be maximizing for the firm to produce. For all prices above the shutdown point, this marginal cost curve tells us how much output the firm will be producing when it maximizes its profits. That's why we call this region of the marginal cost curve, the marginal cost curve above the shutdown point, that's why we call this the short-run supply curve for a competitive firm. And I could label this SS, the short-run supply curve for a competitive firm. Let me repeat. The short-run supply curve for a competitive firm is just the firm's marginal cost curve above the shutdown point. In the next lecture, we're going to be looking now at how this analysis of an individual firm translates into a picture of the whole market. Since all firms, all competitive firms are making these same decisions, coming up with short-run supply curves, when we add all those individual short-run supply curves together, we get the market short-run supply curve. We'll be looking then at how the goings-on in the market influence the situations of individual firms. So in the next lecture, we go from the individual firm to the market in the short run. Last lectures, we've been looking at the profit-maximizing behavior of a competitive firm. That is, what a firm does when it wants to maximize its profits and it cannot influence the price of its product. Well, this raises an interesting question, and that is, where does the price of a firm's product come from anyway? If the firm is taking it as given, well, who's determining it? Who is setting it? We've seen before in our earlier lectures that the price of a firm's product is determined by the interaction of supply and demand. What we're going to do in this particular lesson is show how we can move from the competitive profit-maximizing firm to the supply curve in the short run for the market. Now, let's remind ourselves of a couple of things before we launch into deriving the short-run market supply curve. The first thing is we are dealing with competitive firms, and competitive means that the firm takes the price of its product as given. It cannot influence the price of its product no matter how much or how little output it chooses to sell. The second thing to keep in mind is that the profit-maximizing firm will always produce where the price of its product is equal to the marginal cost of production. That's the condition for profit maximization. And remember, the firm will also be producing on an upward sloping portion of its marginal cost curve so that it's maximizing profit instead of minimizing profit. Finally, one more thing to keep in mind, and that is a firm will shut down in the short run if it cannot cover its variable costs of production. That is, anytime the price of its product drops below the average variable cost, that is the cost of labor per unit of output, the firm will find it better to shut down in the short run. Keeping those three things in mind, we are now able to move from the individual firm to the market. And that's what I'm going to be doing in this lesson. Remind ourselves that we're dealing with the short run. In the short run, some of the firm's inputs are fixed, like the size of its factory, the number of conveyor belts and tools and all of those things. And the way that it can vary its output is by varying its variable input. That is, in our story, labor. By hiring more or less labor, the firm can modify its output. All right, given that we're in the short run, we have competitive firms and they're maximizing profits. What does the short run supply curve for the market look like? Have a look here at these graphs. In these graphs, what I've done is take the situation of three firms, we'll call them Firm 1, Firm 2, and Firm 3, and written down the marginal cost curve and the average variable cost curve of each firm. Well, you'll notice I've already done something a little careless. That is, even though I've indicated that the vertical axes are measuring things in dollars, I haven't put any kind of indicator on the horizontal axis. And if you don't label the horizontal axis, you don't have a graph because you're not telling people what you're measuring. So let me indicate here that I'm measuring the output of Firm 1, television sets, the output of Firm 2 in television sets, and here's the output of Firm 3, also measured in television sets. So what I'm measuring on the horizontal axis in each of these graphs is the output of a television factory. On the vertical axis, notice I'm measuring the same thing in all three graphs. I'll be looking at prices and costs, all measured in dollars. And the scale on my vertical axis is the same in all three graphs. That's why I'm able to put them side by side and take something from each graph and add them together to form a big graph over here on the far right. If you're putting graphs side by side and are planning to use them together, it is important that they are measuring the same thing with the same scale on the vertical axis. So here I have Factory 1, Factory 2, and Factory 3. Over here, in this graph that is vacant for the moment, I put price and quantity on the axes, and that lets you know that I'm going to be deriving what? What kind of graph goes in with price and quantity on the axes? Of course, that's going to be a supply curve or a demand curve. In this case, supply, because we're looking at the behavior of suppliers or producers. All right, so given that we have information on these three individual firms, how can we use that information to derive the market supply curve for the short run? Well, let's remind ourselves what a supply curve is. A supply curve tells us how much output producers will offer for sale at a given price. We assume when we draw a supply curve that producers are responding passively to the price of the product. That is, we're assuming competitive behavior. Well, if we're assuming competitive behavior, we can go over to our individual graphs and say, at a particular price, at a given price, how much output will this firm produce? And we know what the answer is. At any given price, how much output will a firm produce? The firm will maximize its profits by producing where price equals marginal cost. We can follow any particular price over to the marginal cost curve and down to the quantity axis to find the output of an individual firm at any given price. So let's take an example. Suppose the price of our product, and I'll use my clear ruler here to move around and represent different heights in my graph. Suppose the price that we're dealing with is a low price, way down here in the bottom part of my graph. Let's say the price starts out at this level right here, and I'll use my little blue arrow to make clear where we are. How much output will each firm produce if the price of the product is down here where the blue arrow is? Well, notice that none of the firms are going to produce any output in the short run. Why is that? How can you be sure that if the price is down here where the blue arrow is, if we have a low price, that none of my firms will be producing any output at all? The answer is this: because the price is below the minimum average variable cost for each of the firms. The price is below the minimum average variable cost, and we call that point the shutdown point. If the firm can't cover its variable cost of production, there's no point in producing. It's already losing all of its fixed costs. It would just be adding a loss on top of that. So the firm would be shut down. Firm 1 would be shut down. Firm 2 would be shut down. Firm 3 would certainly be shut down if the price were way down here below the shutdown point for the firms. So, as long as the price is below the shutdown point of all three firms, the total market output is going to be 0. So for all prices down here in this region, until the price rises to the point to where some firm can cover its variable costs, we get no output at all. So for all prices over here on this axis, we can start to shade in our market supply curve. We're going to get no output at all until the price rises to a point that's high enough to cover the variable costs of firm 1. Now, I'm going to do a little bit of observation at this point. Notice that firm 1 has got the lowest shutdown point, firm 2 has got the next highest shutdown point, and firm 3 has got the very highest shutdown point. Of all three firms, firm 3 is going to not be able to operate. It won't be able to cover its costs until the price rises way up here. So firm 3 has got the highest shutdown point, or the highest price required before it will produce any output. Let me take a moment here before I go back to deriving my market supply curve and ask, why are the shutdown points for these three firms different? Why do my three firms in my example have different shutdown points? What makes these three firms different? Well, remember, the cost curves summarize two pieces of information. They summarize, first of all, information about the technology of the firm, how the firm is able to turn output into input. It also summarizes information about the price the firm has to pay to hire its labor or to obtain its other inputs. So each of these sets of cost curves tells you something about the technology and the input prices that each of the three firms is dealing with. Now, it could be that firm 1 has a superior technology and is able to produce more output with less labor. It could be. And that firm 2 and 3 just have less productivity for their workers and therefore need more workers and have higher costs to produce output. That's a possibility. It could also be that firm 1 happens to have a bigger factory, more of the fixed inputs. And with more of the fixed inputs, they may need less labor to produce a given number of television sets. They're using tools to substitute for labor. That's a possibility also. So in the short run, it may be true that each of my factories has a different amount of the fixed input. The final possibility would be that the different factories are paying different prices for labor. That is, they're able to pay different wages to their workers. Now, that's unlikely in a competitive market. In fact, by definition, in a competitive market, everybody can hire labor at the going wage. If they were paying different wages, of course, they would have different sets of cost curves. But again, it's kind of hard to believe that these three firms, if they are in competition with one another, would actually be able to pay different wages. They would all end up paying approximately the same price for their labor. All right, so enough of that little digression. Let's go back now to the question of how to get a market supply curve from these individual cost curves. If the price rises, if the price of the good rises to the point where firm 1 can cover its variable costs, then for the first time we have a factory producing television sets. That factory is firm 1. Notice firm 2 and 3 are still below their shutdown points. They're out of the picture, as it were. And firm 1 is able to produce television sets. So if we take the output that firm 1 produces when the price is equal to its minimum average variable cost, I'm going to see here, it looks like 1, 2, 3, 4, 5, 6, 7 chunks on my grid takes me up to here. So let's put this point on the graph. We'll call this P1, and P1 is the price where firm 1 first begins to operate. So I could draw a dotted line over and find the output of firm 1 at a price of P1, and we could call this Y star 1. This is the profit maximizing output for firm 1 when the price is P1. And then I can take P1 on over, moving horizontally across my graphs until I get to the market supply curve. And what I do is I take this quantity that firm 1 is producing and I put it over here in the market supply diagram. That is, when the price is P1, the total market output is going to be Y star 1. That's all the output that we get produced at that particular price. Now, what happens as the price of the product continues to rise above P1? Well, anytime the price rises, firm 1 is going to maximize its profits by going over to the marginal cost curve and choosing the output level where price is equal to marginal cost. So as price rises, firm 1 increases its output by moving along its marginal cost curve. It hires more workers, their productivity is diminishing due to congestion, marginal cost is rising, and that higher price entices firm 1 to produce more output. It allows them to cover the rising marginal cost associated with diminishing labor productivity. So what I do now, over here in this diagram, in the market diagram, is as the price rises, I'm tracing out firm 1's marginal cost curve. I'll be tracing it out here, so let's just take this marginal cost curve and draw it here. As output increases, firm 1 increases its, as the price increases in the market, firm 1 will increase its output of television sets. So this segment right here of the supply curve will be simply the marginal cost curve of firm 1. Remember, the supply curve of an individual firm is what? How do you find the supply curve of an individual firm? Remember, it's just the marginal cost curve of that firm above the shutdown point. That's the supply curve for an individual firm. Now notice, what happens eventually is the price rises to a point that's high enough that firm 2 can now cover its cost of production. Firm 2 can now cover its variable costs, and it enters the market. When the price rises up to this point P2, we'll call this P2 because that's the price at which firm 2 can now afford to enter the market. That is, it's no longer shut down. At the price of P2, and I won't clutter up my diagram here too much, I'll just draw my dashed line over to this diagram and then down. Then we'll call this Y star 2. This is the price and quantity at which firm 2 finally enters the market, P2 and Y star 2. Now notice, this is a jump. This is a discrete jump, a jump in total output, because suddenly we've added another factory that's producing a certain amount of output. So what happens then is I add to the amount that firm 1 is producing at that price, I add the amount that firm 2 enters with. So I have to scoot my market supply curve over and create a new point. I've got a jump here, and that jump is equal to the amount that firm 2 produces when they first start production. So I take this horizontal distance and add it on to my market supply curve. Now, what happens as the price continues to increase? As the price continues to increase, firm 1 continues to move along its marginal cost curve, and firm 2 continues to move along its marginal cost curve. As long as the price is below this high price here, firm 3 is still out of the market. But firm 1 and firm 2 continue to move along their marginal cost curves. So let's go over to our diagram then and add together firm 1 and firm 2's marginal cost curves. This line segment shows how much output is produced by the combination of firm 1 and firm 2 at any of these prices. At a price that's somewhere between P2 and this higher price, we take the amount produced by firm 1, add it to the amount that's produced by firm 2, and we get a point on this segment. Now, as the price continues to rise, eventually what happens is firm 3 finds that it's profitable for it to produce output in the short run. That is, the price will get so high that firm 3 can now cover its variable costs. We pass firm 3's shutdown point. And that will occur at this high price. We'll call it P3. At P3, firm 3 can finally enter, and what it does is it produces a certain amount of output right here. And if we go down to its axis, we can call that amount of output Y star 3. So firm 3 now enters at this high price with its own output. So what we do is take the amount of output produced by firm 3 when it enters at P3 and add it on to the amount that's already being produced by firm 1 and firm 2. And from there on, it's just a matter of moving up the marginal cost curves of all 3 firms. As the price continues to rise above P3, we move along the marginal cost curve of firm 1, firm 2, and firm 3, and that gives us our market supply curve for the higher prices. So that's what things look like. Notice a couple of things about the market supply curve by way of summary. First of all, it has some jumps in it. The jumps occur anytime the price rises high enough to pass the shutdown point of a particular firm. So we have a jump here at P1 when firm 1 is first able to profitably produce in the short run. We have a jump at P2 when firm 2 is first able to profitably produce. And finally, we have one more jump up at P3, that is when firm 3 is able to cover its variable cost when we finally reach the shutdown point of firm 3. So we have these discrete jumps, and the discrete jumps occur whenever a new firm is able to cover its variable costs and resumes operation in the short run. Between those jumps, we have a smooth curve that represents the sum of the marginal cost curves of all producing firms. In this region, only firm 1 is producing. In this region, we're adding together the marginal cost curve of firm 1 and firm 2. And finally, in this region up here, we're adding together the marginal cost of firm 1, firm 2, and firm 3. This, then, is the short-run supply curve for the market. It starts here on the axis because nothing is being produced. It then jumps to the marginal cost of firm 1, the sum of 1 and 2, and the sum of 1, 2, and 3. I've done this example with only 3 firms because, you know, if you use any more firms, the thing is going to start to get really, really messy and complicated and too small to draw on the web. So what you can do then is you can imagine that instead of only 3 firms, we have a very, very large number of firms. With a very, very large number of firms, the the shutdown points are encountered more frequently. Anytime the price is rising a little bit, you're likely to be drawing in another firm. Rather than having these big gaps, the shutdown points will occur closer together. Another thing that happens if the firms are small relative to the market is the amount that they produce when they first start operating is also small. You don't get big jumps, you get smaller jumps, and they occur more often. So if we have not 3 firms, but say 100 firms or 1,000 firms, what we begin to get is a curve that doesn't have all this jumpiness in it. The curve begins to be a smooth curve, and you can imagine it might look something like this. And we call this then the short-run supply curve for the market. This is how we derive it. The short-run supply curve for the market is composed of the sum of all of the marginal cost curves of the individual competitive firms above their shutdown points. To get the short-run supply curve of the market, add together the short-run supply curve of all of the firms that are available for production. And those short-run supply curves will simply be the marginal cost curve above the shutdown point for each firm. The more firms you have, the smoother this curve will be. Now what we'll do is we'll take this information about the short-run supply curve, put it together with the demand curve, and show you how the market adjusts to changes in the short run, and how those adjustments influence what individual firms in the market choose to do. In the We've been talking about how an individual firm responds to a market price to maximize its output. Well, that still leaves the question unanswered. How is the market price determined? What we're going to do in this lesson is put together the supply and demand stuff that we did early in the course with all the stuff about cost curves that we've been doing in the recent lessons. I remember when I took this course, I found this stuff eventually became very confusing. We have all these cost curves floating around, and all of them have different names, and how does that relate to supply and demand? Here's a lecture where we stop for a moment and start to put a lot of things together. Now, I hope you're not confused at this point about the different cost curves, what they mean, and how they're labeled. If you are, you can go back and review some of the earlier lessons. I'm going to do a quick review before we actually begin the supply and demand analysis here. The question we're going to be answering here is, how does the market influence the individual firm, and how does the individual firm in turn, along with a bunch of other individual firms, influence and actually make up the market? So let's look then at these two diagrams side by side. I put them side by side because they're measuring the same thing, price and costs, on the vertical axis. Over on the right, I have the situation for an individual firm. Over on the left, I have the situation for the market. Now, the individual firm is defined by its marginal cost curve, its average variable cost curve, and its average total cost curve. This is what the individual firm looks like in the short run. All right, a few quick review points. Remember, first of all, the short run refers to the period where the firm cannot change its fixed inputs. It has a factory, conveyor belts, tools, all that stuff that's fixed. All of these curves refer to what the firm can do if it modifies only its variable inputs, if it changes only the amount of labor that it hires. The marginal cost curve is eventually upward sloping because labor productivity begins to fall because of congestion of the fixed inputs. The average variable cost tells you the labor cost per unit. If the price isn't higher than the minimum average variable cost, then the firm cannot profitably produce in the short run. The firm will minimize its losses by shutting down. The average total cost curve tells you the total cost per unit produced. If the price is below average total cost, the firm is making a loss in the short run. If the price is above the average total cost, the firm is making an economic profit in the short run. So these curves summarize the technology and the input prices of the firm to tell you how much it costs to produce a given amount of output. Once we put a price into this picture, we can tell you how much the firm will be producing and how much profit the firm may be making. Over here, we have the situation for the market. The market supply curve is simply the sum of the short-run supply curves of the individual firm. Take a moment and ask yourself, what is the short-run supply curve for an individual firm? Where do we get it? The answer is the short-run supply curve for an individual firm is just the firm's marginal cost curve above the shutdown point, above the point of minimum average variable cost. So if we add together all of those short-run supply curves, the way we did in the last lesson, we get this blue curve, the short-run supply curve for the market. Now, here's the market demand curve. That's determined by the behavior of consumers. If you put the short-run supply curve together with the demand curve for the market, you can find the point of equilibrium. The point of equilibrium is the price at which the quantity supplied in the short run is equal to the quantity demanded. If the quantity supplied and quantity demanded are not equal, the price will adjust. Remember the bidding mechanism? The price will rise if there's a shortage, and the price will fall if there's a surplus, until finally we reach the equilibrium price, the price at which quantity supplied and quantity demanded are equal. Now, let's look at this for a moment. We know that this supply curve represents the sum of a bunch of small firms' supply curves, the supply curve of a bunch of competitive firms in the short run. That's where we got this blue curve. Well, given that this is the summary of the behavior of all of these firms, given that this summarizes the behavior of all of the firms in the market, we know that the equilibrium price is going to be right here, where the curves cross. That is, the equilibrium price will be, we'll call this P star, and the quantity that will be produced in the market will be Q star. This is exactly what we did early in the course when we played with supply and demand curves. Now, how does an individual firm respond to this particular price? That is, what is our little firm doing here when it's playing its own part in the market? Well, what it's doing is this. Take the price that's set, follow it over to the individual firm's marginal cost curve, and put a dot there. This is the output that our firm will be producing in the short run. The output is, we'll call this Y star, the profit maximizing response of this firm to a market price of P star. So the first thing is, how much output is our firm producing? And the answer is where price equals marginal cost, and the marginal cost curve, of course, being upward sloping at that point. The second question is, how much profit is our firm making at that point? How much profit? Well, remember the trick for calculating that. Take the price, go over to the curve, and look at how much of its revenue the firm is spending on its various inputs. If we take Y star and go up to the average variable cost curve and over to the axis, we can see that the firm is spending this chunk of its revenue on labor. And if we go up to the average total cost, we can see that the firm is spending this chunk of its revenue, the top portion of this box, on the fixed inputs. Add them together, and it looks like at this particular price being equal to average total cost, our firm is just breaking even. It is making zero economic profits. Now remind yourself, zero economic profits doesn't mean that you don't want to be in business. Zero economic profits means that the firm is just able to cover the opportunity cost of all of its inputs, labor, capital, etc. Everything, including the value of the manager's time. Everything that's relevant here, all of those costs are included in these cost curves. And so if the firm is covering its total costs, it is in fact covering all the opportunity cost of all of the inputs that it's using. Well, in this case, the firm will be completely satisfied and happy about producing. Let's suppose now that there's a change in the market. We're starting with a situation that is kind of nice and stable. The firm is breaking even, it's covering its costs, it's making zero extra profit, zero economic profit, and the market is in equilibrium. Let's suppose now that this firm is producing television sets like before, and let's suppose that the demand for television sets increases because it's summer and the Olympics are going to be broadcast and a lot of people run out to buy a new television set. Well, how would we show that in this picture? How would we show an increase in the demand for television sets because of the Olympics? The answer is the demand curve would shift outward, representing an increase in the quantity of televisions demanded at every price. So our demand curve would shift outward, showing a change in the market. Let me go ahead and draw that new demand curve. It would look something like this. And I'll put my label up here just to try to keep my graph uncluttered. D prime represents the new demand because of a change in the economy. People want televisions to watch sports. Well, given that the demand curve has shifted outwards, we have now got a situation of disequilibrium. At the price of P star, say $300 per television set, the quantity demanded exceeds the quantity supplied. That is, here's the quantity supplied, all of those firms trying to make a profit, producing where price equals marginal cost. They're not able to keep up with the quantity demanded. We have an excess demand at the old price. Therefore, the bidding mechanism pushes up the price of television sets. And as it pushes up the price of television sets, we get to a new equilibrium point. Now, we've done this before. This is just a review. What happens as the price of television sets rises is this. Some buyers decide that they will put off the purchase of a television set. They will go watch the Olympics with a friend. And sellers produce more television sets. We move up along the market supply curve until we reach the new equilibrium point. The new equilibrium point in this case has a higher price for television sets, P star prime, and it has a larger quantity of television sets actually produced and traded. And I could label this Q star prime, an increase in the quantity. What we're interested in this particular lesson is going behind this picture, looking in more detail at how the supply actually ends up changing. How does the quantity supplied actually increase in response to the higher price? In order to see how the quantity supplied actually changes, in order to put this movement under a microscope, we're going to go over and look at the behavior of an individual firm. As the price rises to P star prime, if we take that price on over into our individual firm's diagram, we see that that individual firm now, facing a higher price, will respond by producing a larger quantity of output. Why is that? Why does the firm choose to produce a larger quantity of output when the price goes up? The answer is that at that higher price, the firm can now afford to cover a higher marginal cost. Before, this firm's marginal cost might have been equal to $300. In fact, price equals marginal cost. But if the price of televisions goes up to $400 a television, this firm can now afford to hire some extra workers and turn out more televisions. Maybe these extra workers they're brought in by being hired at the going wage, certainly. But the point I want to make is, why weren't those workers hired before? Why weren't those extra workers hired before? Why weren't those extra televisions produced before? The answer is, at a price of $300 per television set, the firm can only afford to hire so many workers. Those extra television sets here are going to cost the firm up to $400 to produce, because labor productivity is diminishing. If you crowd more workers into your factory and make them work with a given set of tools and a given factory space, eventually that productivity starts to decline as you push more workers in. But if the price of televisions goes up, then it's profitable for you to bring the workers in, even though their productivity is falling. That's the thing you need to know. The firm responds to the higher price by hiring more workers, even though the workers' productivity is diminishing at the margin, even though the cost of producing televisions is rising with a higher price for televisions. This firm now finds it profitable to hire those workers anyway. It wouldn't have hired them when the price was $300, but it will hire them when the price is $400 per television set. All right, so given that the firm now finds it optimal to hire more workers, given that it's now profit maximizing to produce more television sets, what happens to the firm's profits? The answer is this. Before, the firm was making zero economic profit. Now, when it's producing more televisions at a higher price, the firm is actually going to be making some economic profits. See here that the average variable cost when you're producing this larger quantity of television sets is right here. This is what it's going to cost per television set to pay your workers. If you look at the difference between average variable cost and average total cost, this is the average fixed cost. This is what you're having to pay to cover your overhead per television produced. So if we wanted to draw our little parfait again, we would find this chunk of the revenue goes to workers, and this chunk of the revenue goes to the fixed costs. Well, that leaves us with a nice little chunk here on top. If we go over to the average total cost curve, we find that it only takes this bottom rectangle to cover the costs of production. All of this revenue on top is economic profit. Because of the increased demand for television sets, the firms that are producing television sets will find that in the short run, they are able to earn an economic profit equal to the amount of this area. The higher price for television sets leads them to produce more television sets. And because the total cost of production is less than the total revenue they earn, the firm is making an economic profit in the short run. So I could label this pi. Remember, pi stands for profit. Pi is greater than zero. The firm is making a positive economic profit. Will this situation last? Will this situation last? Well, it will last in the short run. But in the long run, what will happen, and we'll be talking about the long run very shortly, in the long run what will happen is new firms will enter this market. Hey, look, this profit is sitting there like a bunch of raw meat on the surface of shark-infested waters. And the sharks are going to start to gather until there's a great crowd of them all fighting over the meat, and the meat is gone. So what you have here in an economy is you've got this chunk of raw meat, this chunk of tasty raw meat of economic profit that draws in the sharks. And not to say that sharks are bad, and not to say that sharks aren't doing what they do when they go after the raw meat. It's what companies do when they see an opportunity for extra profit. They enter. And what happens when new companies start up in this market to enter? The short-run supply curve begins to shift outwards. And when it shifts outwards, the price of the product falls. And eventually the firms will be pushed back into the situation where there are no extra profits to be made. There is no economic profit. Everybody just covers their opportunity cost. This is what happens in a competitive market in the long run. I want to summarize with this question. How did we adjust from this original price-quantity equilibrium to this new one? What happened behind the scenes that gave us the increase in quantity supplied after demand shifted outwards? We can see in this individual firm's diagram that an individual firm responded by increasing its output. An individual firm moved along its marginal cost curve as the price rose, allowing it to cover the increasing marginal costs associated with expanding its output. Put simply, when the price rose, this firm could afford to hire more workers even though those extra workers were less productive and marginal cost was rising. But that's only one part of the picture. That's all we can see here in this little diagram that I've drawn. Something that you can't see here, we looked at more carefully in the last lesson. What's another reason why the quantity supplied is increasing in the short run? It's not just that firms are moving along their marginal cost curve, but what else is happening in the short run that's increasing the quantity supplied as we move along this blue curve? What else is happening in the short run? The answer is, in the short run, firms that were previously shut down are starting up again. Some firms were not able to cover their variable costs. Some firms had average variable cost curves that had minimum points up here in this region, and they were shut down before when the price was $300 per television. When the price goes up to $400, some firms that were previously shut down now resume operation, and they add their output to the market total. So when you move along the short-run supply curve, two things are happening. Individual firms are expanding their output, and firms that were previously shut down are resuming production. That's the short-run adjustment process. You can see some of it in this picture, but some of it you can't because we're only looking at one firm. Anytime the demand curve shifts, there will be this kind of adjustment. An outward shift in the demand curve will increase economic profits for firms in the short run. An inward shift of the demand curve will lead to perhaps economic losses or a reduction in economic profit in the short run. However, in the long run, the supply curve itself will shift as firms enter or leave the market in response to changing conditions. We're going to be going to the long run next. There was a lot to cover in this diagram, and I find that when I give this explanation, students always have questions. I'm going to try to anticipate some of your questions and answer them in this segment. The first question that students often ask is, what causes the short-run supply curve to shift? What causes this green curve to change its position? What leads to a larger quantity of output at any given price? Now, over on the board, I have redrawn the short-run supply curve by itself. And I'm going to talk about the things that would cause the short-run supply curve to change its position. In particular, let's talk about what would cause it to shift outwards. To answer this question, start with recalling what the short-run supply curve is. The short-run supply curve is the sum of all of the firm's individual short-run marginal cost curves above the shutdown point. If you take all of the firms that are in the market at a given time and you add up their short-run supply curves, that is the amount of output they will produce at a particular price, you get the short-run supply curve for the market. It's the sum of the individual firms' short-run supply curves above the shutdown point. Now, what would cause those curves to shift outwards? Well, there are two things that would cause this shift to happen. First would be a change within the firms that are producing currently. The second would be adding more firms. Either of those would cause the curve to shift. Let's start with a change in the existing firms. Suppose the existing firms suddenly have a shift from a few trucks in the short run to a lot of trucks in the long run. If the existing firms acquire more capital, then the marginal product of labor is going to change. If you have 5 workers working with a single truck, the marginal product of labor is going to be very low. But if you have 5 workers working with 3 trucks, then the marginal product of labor is going to be high. Remember, the marginal cost of production is the reciprocal of the marginal product of labor. So when a firm gets more capital, when a firm moves from the short run to the long run and is able to acquire more trucks, then the marginal product of labor increases. And as the marginal product of labor increases, the marginal cost of production decreases. So we could show it this way. We're moving from one set of short-run marginal cost curves with only a few trucks to another set of short-run marginal cost curves that have more trucks. And in that case, the marginal cost of production is going to be lower. It's like we're moving from this particular set of marginal cost curves to this other set of marginal cost curves that are further up the long-run average cost curve that have a lower marginal cost because the marginal product of labor is higher. Now, that's a roundabout way of saying that one thing that can shift out the short-run supply curve is if the existing firms get more capital. As we move from the short run to the long run, the short run supply curve will move outwards because the existing firms may acquire more capital. And when they acquire more capital, labor becomes more productive and the marginal cost falls for the individual firms. All right, that's reason number one. Short run supply curve shifts outward if the existing firms get more capital. The second reason that the short run supply curve will shift outward is adding more firms. In the long run, when there's free entry, the existence of profit in this market will attract new firms into the industry. When new firms are attracted into the industry, those new firms add their short-run supply curves to the market. And that causes the market short-run supply curve to shift outwards. It shifts outwards because we are adding new firms. It's that simple. So what causes the green curve to shift around? There are two things. The first is a change in the fixed inputs of our given firms, our existing firms. The second is adding new firms. You can consider the process in reverse. If firms leave the market, the short-run supply curve shifts inward. And if firms cut back on their capital, that is, in the long run, when they're able to lay off some of their trucks or sell them or return them to the people from whom they've rented them, then the capital stock shrinks. And when the capital stock shrinks, the marginal productivity of labor falls and the marginal cost rises again. So the same two ideas are at work, whether the curve is shifting outward or inward. A change in the capital stock changes marginal product, and that changes marginal cost. That's reason number one. And a change in the number of firms causes the short-run supply curve to shift. That's reason number two. This is the last lecture in our series on productivity, costs, and profits. In this lecture, we'll be looking at the effects of the expansion of an industry, and we'll be deriving a tool that we call the long-run supply curve. Let's start with revisiting the relationship between the market and the individual firm that we derived last time. So here we have the market equilibrium, the demand curve, which is the behavior of households and consumers, and the short-run supply curve, which is the sum of the marginal cost curves of the individual firms. In the short run, the supply curve and the demand curve intersect and give us an equilibrium point. We'll call this P0, and the market quantity, we'll call this Q0. Now, if we take this price over into the diagram for the individual firm, we see that in long-run equilibrium, the firm is making zero economic profit, and the firm is producing at the point of efficient scale. This is a long-run equilibrium. The only way we can have a long-run equilibrium is if no firm wants to change its behavior. In this case, the firm is maximizing profit by producing where price is equal to marginal cost. And the firm is breaking even by producing where price is equal to average cost. There is zero economic profit, and therefore no tendency for entrance or exit. Everything is stable in this market. Let's upset the equilibrium now by changing the demand for the product. If we change the demand for the product, and the demand curve shifts up to this new point D prime, then we have an excess demand for the product at the old price. And the bidding mechanism then will push the price up so that firms supply a larger quantity and the quantity demanded decreases, so that the price goes up to this point here. Now that would be the short-run equilibrium, and the firm would move along its short-run marginal cost curve over here in this diagram. I'm not going to draw the short-run marginal cost because my focus here is on a different story. I want to know what happens as new firms enter the market. What happens to the costs of production? As new firms enter the market and the short-run supply curve shifts outwards, representing an increase in the number of firms offering trucking services, it may be that as these new firms enter the market, that they drive up the cost of production for all firms. Suppose that truck drivers are in short supply. If truck drivers are in short supply, then as trucking companies try to expand their operations, they're going to be bidding up the salaries of truck drivers. And as the salaries of truck drivers rise, then the costs of production for every firm in the trucking industry are going to increase. When this happens, the cost curves shift upward, and the cost that firms can afford to operate at will be rising. That is, the point of minimum long-run average cost will be shifting upwards. So what we have then, as the short-run supply curve shifts outwards and firms enter the industry and compete for a strictly limited resource like talented truck drivers, the costs of production will shift upwards, and we will get something like this. A new long-run average cost curve at a higher level. If expansion in an industry causes the cost curves to shift upward like this, we say that this is an increasing cost industry. If the expansion of the industry causes the cost curves to shift upwards, we call it an increasing cost industry. What we're saying is, as the industry expands, competition for a strictly limited resource will in fact increase the costs of all firms in the industry. This was the case in the computer industry in the late 1970s, early 1980s, when there was a limited supply of talented computer programmers. It took a while for students to go to school and learn computer programming, and of course those students were attracted by the promise of higher salaries. But in the short run, as computer companies tried to expand their operation, competing for a pool of talented programmers, they pushed up programmers' salaries through competition, and that raised the cost of production for all of the companies. Now, what does this mean? It means that there will be a limited amount of entry before the price falls to the point at which firms can just afford to cover their costs. The break-even point for firms has shifted upward as the cost of production has increased. That means the price for the product cannot fall back to its original level, but can only fall as low as the new point of minimum average cost. That new point of minimum average cost might be not 8 cents a mile for trucking service, but 12 cents a mile for trucking service. The increase in costs limits the amount by which the short-run supply curve can shift outwards. This new price, P1, has to be the new equilibrium price. It's the new price that's given by the intersection of short-run supply and demand. It's the new price that we have in long-run equilibrium. Firms are breaking even, and the quantity supplied equals the quantity demanded. If I connect these two dots, I get what we call in economics the long-run supply curve. The long-run supply curve shows what happens to minimum average cost as an industry expands. In our case, we were talking about an increasing cost industry. When an increasing cost industry expands, the minimum average cost of production rises as firms compete for a strictly scarce resource and push up the cost of production. The long-run supply curve in this case is upward sloping. It is possible that you have what's called a constant cost industry. A constant cost industry would be one where, as the industry expands, the costs of production do not change for the individual firms. In that case, the short-run supply curve would keep shifting outward until our price fell back to 8 cents per mile, the original minimum long-run average cost. In that case, the long-run supply curve would be a horizontal line. The short-run supply curve would keep shifting out until it intersected the demand curve at the original price, the original minimum long-run average cost. One more possibility: what if the expansion of an industry actually decreases the cost of production for individual firms? What if we have a decreasing cost industry? What if a large number of firms in an industry actually lowers the cost for each firm in that industry? That could be the case, say, in software design, where you have a bunch of software engineers who work in a market, and with more people trying to solve the same kinds of problems, they're able to solve them faster. They share ideas. Everyone's working on the same problem, and therefore it takes less time to solve it. In an industry like that, a large number of talented software designers lower the cost for each other by working on common problems and sharing insights with each other. That leads to what's called a decreasing cost industry. As the industry expands, the cost of production actually fall. And in that case, the long-run supply curve would be downward sloping. So, a quick summary. The long-run supply curve tells us about the relationship between the size of an industry and the cost of production for an individual firm in that industry. If expansion of the industry pushes up costs for individual firms, we call it an increasing cost industry, and the long-run supply curve slopes upwards. That will be the case if expansion in the industry heats up competition for a strictly scarce resource, like talented programmers or certified truck drivers. It's also possible that expansion of the industry leaves costs unchanged. That's what we call a constant cost industry, and that would give us a long-run supply curve that's horizontal. Finally, it could be that expansion of an industry actually reduces costs for the individual firms. This would be the case if growth in the industry allowed communication among the participants or other ways of economizing on costs, external economies of scale, we call it sometimes in economics, where the growth of an industry lowers costs for everyone. In that case, the long-run supply curve will be downward sloping. A trucking firm, and you suddenly discover that you can charge more for your trucking services than you were able to before. How would you change your operation? And how would your response in the short run differ from your response in the long run? In this lecture, we're going to answer that question, and we're going to do it first by drawing out all of the cost curves that we've studied up to this point. Then we're going to look at how the firm maximizes its profits in the short run when it can make a small adjustment, and in the long run when it can make a large adjustment. Let's draw first the cost curves that will be associated with the firm's choice, and I'll start with the long-run cost curve. I'll first draw the long-run average cost curve, and the long-run average cost curve, I'll draw it with its usual U shape. This long-run average cost curve tells us about the firm's scale economies. Increasing returns to scale when long-run average cost is downward sloping, constant returns to scale at the bottom of the curve, and decreasing returns to scale when long-run average cost is increasing. And I'll label the curve LRAC, long-run average cost. Now, of course, associated with the long-run average cost curve is the long-run marginal cost curve. And the long-run marginal cost curve tells us about the cost of increasing the firm's output in the long run when the firm can achieve the cost minimizing technique. Remember, the long-run curves, the blue curves, always represent the firm's possibilities when it can combine capital and labor in whatever proportions it wants. That is, the blue curves represent costs when the firm can get to the cost minimizing technique, the cost minimizing combination of capital and labor. So let me label this curve long-run marginal cost, or LMC. Let's suppose now that the firm is facing a price that's equal to P sub 0 for its trucking services. Maybe this is 8 cents a mile, and that's what the firm is able to charge right now for providing its trucking services to its customers. What would the firm do in the long run if it could sell its services at 8 cents a mile? How many miles worth of trucking services would the firm choose to offer? The answer, as always, is find the place where price is equal to marginal cost. So follow the price line horizontally across the diagram until we get to price equals marginal cost, until we get to the long-run marginal cost curve. If the price had been higher, say at a price way up here, then the firm would have gone over to a point like this on its long-run marginal cost curve. If the price had been lower, say down here, then the firm would have looked for a point like this. The firm always seeks to make price equal to marginal cost as it tries to maximize its profits. And in the long run, that means being where the price touches the long-run marginal cost curve. Now notice, I've set up this example in a special way. I wanted to make sure that the firm was operating here at the bottom of its long-run average cost curve. That is, it turns out that this firm happens to be at Y sub E, the point of efficient scale. In our previous example, this was 50,000 miles a day of trucking services provided, with 20 trucks and 30 drivers. This is the situation at which the firm maximizes its profits. How much profit is the firm making in this case? I'll give you some options to choose from, and you pick the correct one. Looking at this diagram, in the long run, how much profit is the firm making? The answer is the firm is making zero economic profit because the price of its service is exactly equal to the average cost of providing the service. The firm is breaking even. If the price were higher, the firm would be making a positive economic profit. If the price were lower, the firm would be making an economic loss. But as it is, when the firm is operating at the point of efficient scale, the firm is making zero economic profit. The firm is breaking even. It's making just enough money to cover the opportunity costs of all of the resources that it's using to produce its trucking services. Now, let's consider the short run. Suppose this firm wants to alter its pattern of production in the short run. Remember, the short run is the period of time over which the number of trucks is fixed. We've got a firm with 20 trucks, and it wants to change the number of trucking services that it provides, or the number of miles that it travels, but it can only do so by changing its labor input. It cannot change the number of trucks it uses in the short run. So I'll use my green curve here to represent short run costs, and in this case I'll get another U-shaped curve, and this U-shaped curve will be the average total cost curve for the short run. Now, where did I get this average total cost curve? I held constant the number of trucks the firm used, equal to 20, and I modified labor in order to produce extra quantities of trucking services. If the firm wants to run more routes and provide more service, it's got to hire more drivers and use those trucks more intensively. Or it wants to cut back its output, it's going to have to lay off workers, but it's still stuck with the trucks. So here's the average total cost curve associated with changing output in the short run when you've got 20 trucks. And 20 trucks is the number of trucks that minimizes costs for providing 50,000 miles of service a day. So let's put a little note on here. We'll call this average total cost, and I'll just make it understood that this is the average total cost that's associated with having the number of trucks that's cost minimizing for the point of efficient scale. So in our case, that's 20 trucks in my story. Also, there's a marginal cost curve that's going to cut through this average total cost curve, and it's going to cut through it at its bottom. We know from our previous lecture that the bottom of this curve will also be the bottom of the long-run average cost curve. So there's going to be here an intersection that involves four curves touching at once. And here's the short-run marginal cost curve. And let me put SMC here, where the short-run marginal cost curve is the one that's associated with the point of efficient scale. Well, I've got two more questions to answer before I feel like this diagram really makes sense. The first one is, why can you be sure that the green average total cost curve is everywhere above the blue long-run average cost curve? Why is the average total cost in the short run always higher than the long-run average cost? You give the answer. The answer is, in the long run, the firm can always change capital and labor both in order to get to the cost minimizing technique. In the short run, the firm does not have that flexibility. It can only modify its labor input. It can only change one input. Therefore, the costs are always higher in the short run because you can't get to that cost minimizing technique. In the long run, of course, you can. So the costs of production are always lower in the long run. Next question. How can I be sure that the short-run marginal cost curve lies above the long-run marginal cost curve? Why does this short-run marginal cost curve go above the blue long-run marginal cost curve when my firm expands its output? The answer is, in the short run, if you want to expand, you can only do so by hiring extra labor. In the long run, if you want to expand, you can hire more labor and more capital and do so in the combination that minimizes the cost of expansion. See, if you can't get more trucks, you may have to use a whole lot more workers than you'd otherwise like to, just to use those trucks more productively, or really load workers in so they're always running at maximum peak productivity. However, in the long run, when you can modify both workers and trucks, you have the flexibility to combine them to find lower cost ways of expanding your output. In the long run, you have more options, and more options equals lower cost of expansion. Now, here's one more point, and this point's kind of subtle. So if I don't make it clearly enough for you the first time, don't worry about it and just go on. But give it a shot and see if this works. If we reduce our output, why is it in the short run that costs will be reduced less than they will be in the long run? If we cut back our output from 50,000 miles of trucking service down to 40,000 miles of trucking service, how can you be sure that in the short run our costs will fall less than they would fall in the long run? The answer is, in the short run, when we try to cut back our output, we can only lay off workers. We can only reduce the labor input. And we may have to only lay off 2 or 3 workers before we've got trucks that, can't be used productively. We've got to be careful in the short run about how many workers we lay off, or our output could start to fall very rapidly. In the long run, however, if we want to cut back our services, we can lay off both labor and capital, and lay them off in those combinations that allow us to maximize our cost savings. In the short run, we have less flexibility, and less flexibility always means less cost savings when you're trying to reduce your output and cut back. In the long run, whenever you can both lay off workers and reduce capital input, then you get bigger cost savings. Your marginal cost is higher. That means you can lower your costs faster, or faster is the wrong word. You can lower your costs by more if you have more time to adjust both inputs than if you can only make one adjustment, that is, adjusting labor. All right, so what I've done here is I've explained this important point of intersection. I've explained why the green curves are above the blue curves, and we've discussed this particular point of efficient scale. Now we're ready to do an experiment. Suppose instead of 8 cents per mile, our firm is suddenly able to charge a higher price, maybe due to increased demand for trucking services. If that's the case, then what happens is the firm now faces a higher price for its product. And with a higher price for its product, the firm is going to want to expand its output. Let's figure out now what the firm is going to do in the short run. In the short run, with this higher price, the firm would like to get a piece of this action, expand its services. However, it's limited in the short run. What's its limitation? It can't get more trucks. It can only expand its output by hiring more workers and crowding more workers into the trucks to try to use those trucks more productively, keeping them running all the time, scheduling workers between trucks so that the trucks are never idle. In the short run, we can only get increased output by expanding the variable input, labor. That means we're going to be on the green curves in the short run. So where's the firm going to go? How much extra output will the firm produce in the short run with this higher price? Locate the point in the diagram that represents maximum profit in the short run. The answer is follow the price over to the short run marginal cost curve, and that gives you the profit maximizing output in the short run. What's going to be happening? The firm is going to be trying to provide more trucking services by using more workers, hiring more workers. Instead of running one-person crews, we may have two-person crews, two drivers in a single truck, so that the truck is used more productively and we get a few extra miles out of it every day. We may have more workers working between trucks, 8 hours in one, 8 hours in another. The firm may incur the extra cost of flying workers around so that they meet up with trucks that need a replacement driver. All that stuff will happen. And what's going to happen when we start crowding more workers into our given number of trucks? What's going to start happen when we start packing more workers into those 20 trucks is that labor productivity continues to fall. And as it does, the marginal cost of production rises. See, this is how it works. The higher price gives the trucking firm the latitude or the flexibility to hire the extra workers that push up marginal cost. Those extra workers are expensive, and getting extra miles out of your given fleet of trucks means using labor packed into trucks at a higher labor-truck ratio, and that's going to lower labor productivity. As labor productivity falls, the cost of production rises. And if it weren't for this higher price, the trucking company couldn't afford to pack workers into trucks the way they're doing. But the higher price encourages the trucking company to hire the extra workers in the short run. So output increases, and output increases maybe to, let's say, to 50,000 or 55,000 miles of trucking service provided a day. So we get a new higher output, and we'll call this new higher output Y1S. So in the short run, we get an increase of output. Now in the long run, what's going to happen? Oh, by the way, notice also, is the firm making a profit in the short run? Sure they are. Go from the price down to the short run average cost, the average total cost in the short run, and this gap right here, multiplied by the number of miles of service provided, is the firm's profit in the short run. There's a short run profit because price is greater than average total cost, as we see by looking at the difference between price and the average total cost curve above 55,000 miles. What's going to happen in the long run? In the long run, of course, the firm is going to say, look, if we can charge 10 cents a mile for our service, we're going to get a bigger fleet of trucks. And as the firm employs a bigger fleet of trucks, they're going to find it optimal to change their labor to match the bigger fleet, and they're going to find the cost-minimizing technique for providing a larger quantity of service, for serving more miles a day. So as we move from the green curve to the blue curve in the long run, the firm is changing both labor input and capital input, more trucks and more drivers. Changing the two in whatever combination gives us the minimum cost of providing that quantity of service. So notice in the long run, the firm will end up producing more output than they do in the short run. Because in the long run, the firm has more flexibility and they're going to be able to make more profit. Notice profit is bigger in the long run because costs in the long run are always lower. This gap is bigger in the long run than it is in the short run. So in the long run, when the firm is able to modify both its capital input and its labor input, the firm does two things. It produces a larger quantity of output and it makes a bigger profit. It's always good to have the flexibility that comes with the long run, because in the long run, you can modify both capital and labor in order to achieve the cost minimizing technique. And anytime your costs are lower, you're probably going to want to expand your output. So, quick review. I started with the short and the long run cost curves together in one diagram. And I discussed the relationship among these curves, what determines their positions relative to each other. Then I did an experiment. I raised the price that our trucking company can charge for its services from 8 cents a mile to 10 cents a mile. And I looked at the response of the trucking company in the short run and the long run. In the short run, the trucking company can only expand its output by hiring more workers. So it does so, but the costs rise very rapidly because labor productivity declines quickly if we've got to keep packing workers into the same old trucks. In the long run, however, costs rise more slowly because the firm can modify both its capital and its labor. It can get more trucks and more drivers. So because it takes longer for the costs to catch up, the firm is able to increase its output more in the long run because it takes a bigger range of output for the marginal cost to catch up with the price. In the long run, the firm produces more output and the firm makes a bigger profit. In the next lecture, we'll look at how a single firm responds to a change in the market.